Bismillahirrahmanirrahim. Assalamu alaikum. How are you, my students? Hope you are doing well. So, Mrs. Sobia Suhail is here again with the topic of factorization. Factorization. For this, already I have explained and I have taken the questions from the reference from the 8th class countdown, unit number 14. 14 and exercise 14b I'm doing. I have done question number 1 to 8 in my previous videos. So this part I will start with the question number 9. So basic all methods of the factorization I have explained already, which can solve the quadratic expression. So this question is a4 plus 4a square minus 5. It's a little bit different because in the previous question what happened, a clear quadratic expression was given. Okay, now here it is fourth power and here it is square power. So if you observe easily, this can be, if you are taking a square as equal to, let's suppose I'm taking x. Okay, taking square on both sides, this side and this side. So this become a4 and this become square. So it means that we can take this one and replace this with these value. Let a square is replaced by x and a4 replaced by x square. So replacing this one, it will become x square plus 4x and minus 5. It's okay. Now it's the perfect quadratic expression which we know how to solve before, and about that I told you factorization method. The first factorization rule, always check common. Once you can check that no common factor, then go to check whether the first term is a whole square and the last term is a whole square. So completing square method will be applied. Otherwise go for sum and product term. Okay, so for this one, write down here sum and product. The sum is called the coefficient of middle term, that is 4, and product is called the coefficient of first and the last term, product of them. Means 1 5s are 5, plus minus minus. Now factorize the product number. Okay, as 1 is the factor of any number, 1 5s are 5. On subtraction, this can give you 4. On adding, it is making 6, but on subtraction, it is giving 4. When it is giving this sum answer on subtraction, so we use this symbol with the bigger number and opposite with this number. It's okay. Check again. Sum of these opposite integers are giving you some number and product is giving you product number. So we can select this pair. It's okay. Now 4x is splitted into two terms, that is minus x and 5x. Okay, so write down this x square minus 1x plus 5x. 1 no need to write, that's why we're not writing. Now instead of the 3 terms, now 4 terms are there. Whenever we have 4 terms, we try to make pair of terms to take something common. Okay, from the first 2 terms, clearly x is common. Out of x square, 1x common, 1x left, x divided by x, 1 answer, plus 5. When first term divided by 5, x left, minus 5 divided by 5, 1 answer. It's okay. Now x minus 1 same. So take it common and here left x plus 5. Until here your expression is completely factorized. Okay, but whenever we are taking or supposing any value with respect to the other value, we have to return that value. We have to return. So replace, what was x? X equals to a square. Replace x with a square. When we are replacing, so our question will be turning to x is a square minus 1 and a square plus 5. Okay, recall your algebraic identities again. Factorization rule on this one. Check common factor, there is no common factor. Check the square terms. This is whole square of a, this is whole square of 1. 1 is the square number of 1 and center is minus sign. Whenever we have this condition that first term is the square and second term is the square and center is minus sign, so we know that this is algebraic identity and it is open as a plus b and a minus b. So we will use this identity. Okay, so first express them as a square of a, express them as a square of 1, and then open it as a plus 1 and a minus 1. Now come on to the second factor. This is the whole square, this is not a whole square, and there is no minus sign in between also. There is nothing common, only two terms are there, so no identity can be applied here, so we can leave it as it is. We will continue it as it is, a square plus 5. Okay, so until here all the factors are in complete simplification form. Next factors cannot be possible from here, so we have to stop our factorization procedure till here, from the start till the last. Okay, so this question is solved. So the next question number 10 in the same exercise is exactly on the same pattern, so let me continue that also. Okay, so question number 10 is, but I will go in a little faster pace. Minus 28. Again there is square term, there is fourth term, so what we can do, let x square equals to, you can say now y. Okay, taking square on both sides, square on this, square on this, it become square to square, means 2 2s are 4, y square. Okay, now use this value, use this value, x4 replaced by y square, x square replaced by y minus 28. Again this is a square number, this is not a square number, so we will go for mid-term breaking method. Mid-term breaking method. Every part almost I'm explaining you about the factorization rule. Check whether we can take common. No, we cannot take. Check it's the whole square number or not. So they are not whole square number, this is not a whole square number, so we cannot take common, we cannot go for completing square method, so we have to go for mid-term breaking method then. Okay, so for this one we will write sum and product. There are different ways of taking the sum and product also, but I like this one, and I feel that my most of the students during when I explain the lecture, they said that this method is comparable, very convenient, so I'm explaining in the same way. Sum is, what is the sum? The coefficient of middle term plus 3. What is the product? Product of first and the last term, that is minus 28. Okay, factorize this product. Check the factor of 28. 1 is a factor of every number. Okay, but sum and difference cannot give you this. 2 14s are 28, but sum and difference not giving you 3. 3 cannot divide 4. 4 7s are 28. Its difference can give this. When it is difference can give this, it means they can be the integers with opposite sign. Okay, so this sign with the bigger digit and opposite sign with the small. Now their sum is giving this and their product is giving the product number. Understand that point? Their sum is giving this, product is giving this. So instead of 3, we will write two terms. Okay, minus 4 same variable, plus 7 same variable, minus 28. Okay, so take common y, then y minus 4 left, plus 7, y minus 28 divided by 7, 4. Y minus 4, y minus 4, take it common, y plus 7 left. Now it is completely solved. Quadratic expression is completely solved as we take the help of y. So we have to replace the value of y. Replace y is equals to what? What we have taken? X square. Replace, and that it will become x square minus 4 and x square plus 7. Now check in this one also. This is a whole square number, this is a whole square number. So again using the identity whole square number, this is square of 2. It can be open as x plus 2 and x minus 2. And what about this one? They are not whole square, so they will stay as it is. Okay, thank you so much. If you like my video, if you like the teaching style, so please subscribe to my channel. Thank you so much. Allah Hafiz. Until then, I will make the next video for the next part. Thank you so much.